Hi, ladies. So today we're on day 6 of chapter 4. So we're getting close to wrapping up. So our outline for today is prayer, some updates. There's no prime time. We'll review your homework from last time. Class content's going to be going over a lot of stuff with the periodic table and some kind of miscellaneous things, going over classwork and looking ahead. So our prayer requests that we have still on the Google Doc are here. So take a moment, take a look. A lot of people to keep in our prayers. So I'd like to say in our Father today. So in the name of the Father, the Son, and the Holy Spirit, amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as in heaven. Give us this day our daily bread, and forgive us our trespasses as we forgive those who trespass against us. And lead us not into temptation. Amen. In the name of the Father, the Son, and the Holy Spirit, amen. And that was some 2 cents from my dog. All right, so class update. Math videos, I've posted 3 temperature conversions, unit conversions, and SI unit conversions. I've sent and emailed the chapter 2 part 2 test to everybody. I will discuss and post the answers when I can. I also know there's some emails that I need to address, and I'll try to get to those. Curation project. So I'm sorry that elink.io has changed what you can do with the free account. So the last 5 resources will either need to be in a new elink.io website, or you're welcome to use Google Sites. Please do whatever is easiest for you. Google Sites is very easy to use and similar enough to elink.io that you should be able to use it if you prefer. The due dates, May 5th with 3 new resources and May 19th with 2 new resources. And this should be the same website for these 2. And I will need the website link when you turn them in for May 5th. Rubrics are going to be the same as the previous rubrics, including 5 sentences explaining why you selected your topic, why you selected your resource. Everybody has copies of those rubrics because I've emailed them to you when they were completed with your last set of curation resources. So another update, personal update. Over the weekend, I've gotten sick, and you may remember back in the fall when I was in the hospital with diverticulitis. Well, that flared up on Saturday. I've been pretty much bedridden Saturday and Sunday. Today, I'm feeling a little bit better. Antibiotics are kicking in. I talked with a doctor again on Wednesday, and so I should be able to avoid going to the hospital, which will be really good. But that is why I have not responded to a lot of the emails. I've tried to pay attention to the ones that were urgent and needed to be responded to. But if you sent me something that was late or that I needed to grade or enter a grade for, and I haven't done it, that's why, because I just have not been feeling well over the weekend. So another thing on the personal update, last time I was going to show you a video of one of the bands that I play with that's here local, and I didn't get to it because I felt like I was running out of time last time. So I wanted to share that with you tonight. We were supposed to have a concert in March, right around the time all the schools closed, and so we didn't have this concert, but we ended up putting together, at least some of the musicians put together this video of us playing one of the songs that we would have played for the concert. So you may recognize it. It's called Rockin' Robin. So you guys may or may not recognize that particular song. So that is one that we ended up doing because we didn't end up having our concert. Okay, let me get that stopped. So that's one thing that I've done over the time that we've been out. This was done over spring break. So then last time I was showing you some pictures from Singapore, and this is kind of winding down pictures from Singapore, but there's a lot of really good food in Singapore, and it's partially because there's a lot of different cultures that are represented living in Singapore. So we've got Chinese and Indian and Malaysian and Indonesian, Filipino. So a lot of the Asian countries have had a lot of people migrate to Singapore. One dish that's actually local to Singapore is his Hainanese chicken rice, and the chicken is boiled. The rice is boiled in like a chicken broth, and it's served with a number of spices that are really good. There's a ginger sauce, which is really good, a dark soy sauce, and some hot sauce. But this is one of my family's favorite dishes there. So this is Hainanese chicken rice. This is roasted chicken rice, which we also really like. The rice is the same. It's just the chicken is cooked differently. There's also chicken biryani, which we love, which is an Indonesian dish. There's a lot of things here that look very much like different Chinese dishes. There's black pepper crab. There's other shrimp dishes. So a lot of really good food. There's these long baos, which are dumplings, and these are pretty popular. They're well known here for their different flavors, and all these different colors come from different flavors. A lot of the food looks very Chinese because there's a lot of Chinese, very high percentage of Chinese living in Singapore. Hot pots are very common there, and they're very much like fondue or broth fondue. So this is I think this was like a vegetable broth with a lot of mushrooms and some cabbage in there. And then we cooked our meat and put them in to the broth and then fished them out with chopsticks, which can be very challenging because the meat starts falling apart after it's been in the broth for a little while. So you end up hunting, trying to find the pieces of broth or pieces of beef in the broth. But it's very good, and it's very common in China also. My husband ate it a lot when he was traveling to China a lot, and we also had it a couple times when we were there as tourists. There's other things that look very familiar. Shrimp fried rice. This is black pepper steak. This was a shrimp dish that just was very lightly seasoned. There is some chicken over here. This was a very hot and spicy soup. I don't remember the name of it. I didn't have any of it because the broth is really, really spicy. Actually, my husband's eyes water with it, but he really likes it. So this is kind of typical food for eating there. And the other interesting thing about it is that it's very inexpensive to eat. So we would go to what was called hawker stalls, and you would normally get a plate of food like this for like $2.50 or $3. Very inexpensive, where the locals eat, and it's also very safe and very clean. The government keeps an eye on the places, and they are very serious about ranking them and ensuring that they're clean and they're safe for people to eat. And they have their ranking displayed so you can see it when you're there. And the different hawker stalls don't sell a whole lot of different things. So like the chicken rice stall will only sell this, and that's all they sell. Nothing else. The rice and the vegetable and this broth is all the same. The only thing that's different is the chicken is either roasted or boiled. Chicken biryani stall, that's all they're going to sell. They aren't going to sell anything else. So, but it's still really very, very good food. So on to our current material, chapter 4 topics. We've worked our way through pretty well. We're going to talk about a lot of stuff with the periodic table, so groups and periods, metals, nonmetals, metalloids. And then next time we're going to talk about ions and start talking a little bit about ionic compounds. So one really short video that I found that I wanted to show you is a dancing penny experiment. And this is actually something you can do at home. So they took a glass bottle and a wet penny and put it on the top so it kind of covers the opening. Then you hold the bottle with your hand and the penny jumps. So the water seals the bottle and the heat from your hand causes the air inside to expand and the penny to jump. So this is a demonstration that you should be able to do with a water or a bottle, glass bottle that you have at home. I don't have one, so I really couldn't do that. However, I know this works because it's very similar to the bottle that I showed you in class that we had the soap bubble and then we heated it up and you could see the bubble expanding. So when I saw that, I thought that was kind of neat because it's the same concept just being shown a little bit differently. So going over some answers from last class, green page 22, number 4 was the only one we did not do, and this was the atomic mass of sulfur, in which you have 4 common isotopes. And when I summed these percentages, they didn't quite reach 100%, but I'm assuming that because it's only 0.006 off, that has to do with the sig fig somewhere in these numbers. So the atomic mass, and I said oxygen, it should say sulfur here. So it ends up being, when you add all these together, I got 32.06 AMUs, and then after I round, I got 32 AMUs, and that's cocoa. So next one, and now she's really going to get going. Okay, on page 18, I noticed last time when I was setting up for this video that when we did number 3 and it said round to the nearest thousandth, I did not round the final answer to the nearest thousandth. So I had 1.0345 AMUs, and if you round it, you should end up with 1.035 AMUs. So I wanted to correct that from last time. And then number 4, you should end up with 39.135 AMUs, and number 5 is 55.910 AMUs. And the work is all shown here if you need to take a look. So your models for your 2 isotopes that you were supposed to do for today, I'm going to go over these next time because I want to take a look at your models that you made, and we'll be using some of these on Thursday. So if you didn't get those turned in, please go ahead and do those, and I am not going to go over the answers until after Thursday. So green packet, page 8. So there's a number of things for you to fill in here. We have at the top, this is all information about chemical reactions. So a chemical reaction is a process in which atoms of one or more substances are rearranged in order to form new substances. And chemical reactions are occurring in your body as you read this. For example, the process of cellular respiration shown below is a reaction that helps release the chemical energy stored in food as a form of energy that your cells can use to supply their energy needs. And I believe you would have talked about cellular respiration last year in biology. In the second section, it says, to understand chemical reactions and the importance they play in our everyday lives, it is essential that you know how to read a chemical equation. So reactants are the starting substances, usually to the left of the arrow, and products are the substances formed during the reaction, usually to the right of the arrow. So practicing by placing a box around the products and a circle around the reactants. And you can see here that we've got a circle around these 2 and a box for the products around these 2. So various symbols that are in our chemical reaction equations. A plus sign separates substances in a chemical reaction. This arrow is a yield sign and it separates reactants from products, just like we have here. An arrow that goes both backwards and forwards indicates a reversible chemical reaction. Parentheses with an S indicates the substance is a solid. Parentheses with an L indicates the substance is a liquid. Parentheses with a G is a substance is a gas, and parentheses with an AQ indicates the substance is in an aqueous solution state. So aqueous or aqueous, depending on which way you want to pronounce it, is water. So this tells you that something is dissolved in water and it's a homogeneous solution. Many things that we have are dissolved in water, and so this AQ is very commonly used. So I'm guessing that a number of these things you've seen, like reactants and products before. You may not have seen like solid, liquid, gas, and aqueous solution being referred to in all of these, or may not have recognized it, but I'm betting that this is not going to be exactly hard or challenging for you. So on the other side of the page are going to be some information that we've already talked about this term. The subscripts are the small numbers directly to the right of the elemental symbol. Subscripts indicate the number of each type of atom that make up a particular compound. Looking at H2O, this means that in one molecule of H2O, there are 2 hydrogen atoms, H, and 1 oxygen atom, which is O. So using the chemical formula H2O as a guide, determine which of these circles represent hydrogen and which represent oxygen and label them within the appropriate circle. So since there are 2 hydrogen, those must be these white ones down here on the bottom, and there's 1 oxygen that must be the shaded in one here on the top. In the next section, we've got coefficients. It's the number written in front of each reactant or product. If this number is a 1, then we don't normally write it. Coefficients tell you how many of each compound there are in a chemical reaction. For example, in the equation above, there's a 6 in front of the O2. This means that this reaction has 6 molecules of O2 as one of the reactants. So practicing down here, you place a triangle around the subscripts. So you're going to place a triangle around each of these subscripts, and then you're going to underline the coefficients. So all of the ones here in front and the implied number 1 out in front of the oxygen here. So skipping ahead in your packet to page 23, we have a brief introduction to the development of the periodic table, and this talks about 2 different gentlemen who did a lot of work on our periodic table. The first one is Dmitry Mendeleev, and he's known as the father of the periodic table because he was the first to publish a table arranging the elements by increasing atomic mass and through observation of all of their different properties. So Mendeleev's version of the periodic table ends up being revised later by a gentleman named Henry Moseley, and he's known as the father of the modern periodic table. And his version of the periodic table was rearranged by increasing atomic number based on his discovery of the actual nuclear charge of the element. And this is what we use today. However, Mendeleev's arrangement by increasing atomic mass is very, very similar to what we know in what's on our periodic table today. There's only a few elements that end up swapping places if you arrange it in terms of atomic mass instead of atomic number. So both of their contributions are really important. However, we do use Moseley's version, which has increasing atomic number. So when we organize the periodic table, there are a lot of things that are really helpful in arranging it in this manner. So periods are horizontal rows from left to right, and there are 7 periods in the periodic table. So that means that there's 7 rows. So 1, 2, 3, 4, 5, 6, 7. So if I look at 2 elements that are, let's say, like right here, which is lithium and beryllium, they're right next to each other on the same row. They are in the same period, and that is period 2. We call the columns families or groups, okay? And there are 18 of them, and your periodic table is numbered 1 through 18 for these groups. Your periods, these rows, are not numbered on your periodic table, but you're welcome to write on your periodic table and do that. So on the families and groups, these vertical columns, if we look at something in here, we've got helium and neon. These are in the same family, and they end up having the same or very similar physical and chemical properties. So it's very helpful to us when we have the periodic table organized like this, so that we are able to look at it and gain a lot of information just from its organization. So with the families, we've got a lot of information that we used a couple classes ago when you were coloring this periodic table. So we've got the alkali earth metals, which are this first column, and the alkaline earth metals, which are in this column, and it does not include hydrogen. And then over here, we've got halogens and noble gases. And these 4 families have special names for a number of reasons, and we will use those special names. You'll actually use them later on today in some of the classwork, but we refer to all of these things by the fact that they're halogens because they have very specific properties. Same with noble gases, then alkali earth metals and alkaline earth metals. And then all of these ones in the middle, we've got transition metals and post-transition metals, metalloids, nonmetals, and then we've got the lanthanide and actinide series. So all of these are grouped and colored in this way because they have very similar properties within their group or their family. So my family has an element collection, and it looks like this. And you can see we kind of color-coded our things based on those families and groups. So we've got the alkali and alkaline earth metals, we've got halogens, we've got noble gases, and we've got nonmetals, we've got the metalloids, and the bulk of things are over here in the metals section here. So a lot of elements that we've collected over the years, many of these are fairly pure or very pure. And this was collected because of a gentleman named Theodore Gray. And when my daughter was younger, I bought a book that was by him called The Elements. And it's very interesting because it has a lot of information about the various elements and some really neat pictures of samples of those elements by themselves or in compounds. So when I was looking up the information about this, I found the promo video for this book, and I wanted to share that with you today.
Where is, because any place you can be is a place made of elements. Everything you see around you, anything you could drop on your foot, that is a thing made of elements. But how many of them have you seen in their pure form? So here they all are, set in the immortal words of Tom Lehrer to a possibly recognizable tune. There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodium, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, magnesium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered. elements ranges from the soft but explosive luster of potassium to the expensive neighborhood of the platinum metals to the even more expensive diamond electrum of carbon. From the familiarity of tin to the exotic shine of hafnium to the edgy world of the radioactive elements, I've tried to capture all of this in my book, The Elements. I spent 7 years gathering these objects. You will not find a more diverse or colorful book of the elements anywhere. Every element has 100 stories, and I've tried to tell a few of the most interesting ones about each element. If you've ever wondered what the basic building blocks of the universe look like, I give you my book, The Elements.
So his book is actually really well done. I wanted to point out one thing in his table here, which is kind of interesting. So over here, we've got the noble gases, and you may be familiar with neon signs, or what you refer to as neon signs. And true neon signs are only going to be this color. So this color, reddish orange. Any other sign that might be glowing like that, if it's a different color, like any of these other colors, it's not neon. So just a piece of information for you. We do refer to a lot of these signs, regardless of color, to be neon, but the only ones that are truly neon are this reddish color. So, if you kind of like that song, Daniel Radcliffe does a version of it from a TV show that he was being interviewed for, and it's kind of interesting to hear him go through that song also. So if you're a Harry Potter fan or like Daniel Radcliffe, you can Google that and take a look at that. So normally what I do at this point in time is I brought in the Maurer periodic table and shown that to you. And at that time, I also hand you a gift, which is a copper penny. This is larger than a regular penny. It's, I don't know, double the size. I had another picture that I thought I put in this PowerPoint, but obviously it's not here. And this is kind of like a gift from me to you. And it's a fairly pure, almost pure copper coin. This is kind of like the beginning of an element collection or something fun for you for chemistry. When you do get it, I recommend not getting the oils from your fingers all over it because it will tarnish. And normally, since I pass these out in class, it's not an issue. However, since we're not in class, what I think I'm going to do is by the time we find out that we can collect your books and be back at school, I'll find a way for you guys to pick these up in our classroom in some manner, however that works. So this, I already have these and they'll be there for you when we get that opportunity. So moving on page 23 on the right-hand side, we've got some information to write down about metals, nonmetals, and metalloids. So metals are found to the left of the stairs except for hydrogen. So last class, actually 2 classes ago, I had you color in page 25 in your periodic table, which looked like this. So that is this section in here, so we're not going to go ahead and recolor this. But metals are the stuff found over on the left-hand side, except for hydrogen, because hydrogen's a gas, so it's definitely not a metal. Metals are good conductors of heat and electricity. They're malleable and they're ductile. So they're malleable so they can be hammered into thin sheets. They're ductile so they can be drawn into wires. And you kind of remember those terms maybe from when we were talking about physical properties, hopefully. Non-metals are found to the right of the stairs, and that includes hydrogen because it's definitely not a metal. Again, because it's a gas. So properties, they're poor conductors of heat and electricity, with the exception of carbon. They're very brittle. They'll shatter if hit with a hammer or other object. That's true of the solids. Then we've got the metalloids, which are the ones along the stair step, and they are found along those stairs with the exception of aluminum. And they have properties of both metals and nonmetals, can conduct electricity under certain conditions. And this little section here is kind of a review to remind us about the information that's displayed in the periodic table. We've got an element name, we've got the atomic number, we've got the symbol, and we've got the atomic mass. So if you need to pause the video to copy those down, go ahead. So on page 25, which you guys already colored in, it's important for you to know which elements are metals and which are nonmetals, because in the next chapter, when we talk about how to name compounds, it's important to know whether you have a metal and a nonmetal compound or a compound that has two nonmetals. And if we don't know the difference between them, we're never going to be able to name them properly. So this representation of your periodic table where you have these colored is going to be really important for you moving forward in chemistry. So page 26, I believe, is the next page that we haven't talked about. And numbers 1 through 4 are things that I don't expect you to have memorized. And so I just giving these to you for you to write down. So elements that form liquids at room temperature include bromine and mercury. Elements that are gas at warm room temperature: hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, and radon. And then name 5 elements that form solids at warm room temperature, and it's pretty much everything that's not these, but some of the common ones and the ones that were written on this answer key include cobalt, copper, zinc, sodium, and magnesium. And 5 elements that we don't know what the state of matter is include those, and these are these things that are down in this region of the periodic table. So the rest of this page, I'm going to have you do on your own. So remember, families are looking for names like alkali metals, halogens, noble gases. Periods are looking for the row numbers. So you're going to count the rows and you're going to put the number here. Metals, nonmetals, metalloids, you're going to look at the page that we were just looking at, page 25. Atomic number of all of these, you should be able to find those on the periodic table, and atomic masses are also on your periodic table. So this should be relatively easy for you to work on and complete. Page 17 also should be pretty easy for you to work on and complete. This is one that I normally do in class, kind of as a race, but we're not in class, so we can't do it this way. So this is based on the basketball brackets for the Sweet 16. So what you're going to have is in the first round, you're going to look at each of these pairings and determine which one wins and moves on to the second round. So it says here for the first round, the element with more protons wins. So you're going to have to look up how many protons each of these has. You should be able to do that because you know the atomic number is the number of protons. And the winner of that will go on to the second round. So you'll write that element over here. And you're going to do the same thing for iron and phosphorus, and you're going to write that element there. So once you've done the whole second round, you're going to look at here. It says the winner is the element with the symbol that is first alphabetically. So in alphabetical order, which one comes first? And you're going to have to remember that some of these symbols are not based on the name, at least not the name in English. So you're going to want to remember what those symbols are. You may need to look a few of them up if you don't happen to remember. And once you do that, you compare these pairs, you'll know who goes on to the semifinals. In the semifinals, you're going to look at the element most often used in magnets, and those you're probably going to have to just look up on the internet and find out which of these pairs will be the ones who goes most often in magnets. And then you'll be down to 2 elements here in the final round. The winner is the one that has the lowest atomic mass. So you're going to end up looking at these 2, looking at the periodic table, finding out which one has the lowest atomic mass, and you'll end up with a winner. And everybody should end up with the same answers. So take a look at this and pause this if you want to do this now, or you can come back to it later on, but we are getting close to the end. Okay, green page 27. I just want to do the left-hand side today. We're going to do the other side later on. So at the top, it's got another really bad pun. I've got my eye on you. So this is for ions. So remember, number of protons determine what atom you're talking about. And as you've already learned, atoms of the same element can have different numbers of neutrons. So atoms can gain or lose electrons. And when they do that, they're called ions. There are 2 types of ions. There are cations and anions. Cations lose electrons and become positively charged because they now have more protons than electrons. So for example, calcium 2+. What does that 2 plus mean? It indicates that the calcium lost 2 electrons. So now it has more protons and less electrons. Anions are atoms that gain electrons and become negatively charged. So we've got nitrogen with a -3. So the -3 indicates that nitrogen atom gained 3 electrons. So now it has more electrons than it does protons. So in the next section, checking for understanding, place a circle around the anions and a box around the cations. So go ahead and take a moment and do that. And here are the answers. We've got circles around all the negatively charged ions, and we've got boxes around all the positively charged cations. Checking for understanding part 2, determine the number of protons, neutrons, and electrons for magnesium 2+. So going back to our periodic table, magnesium has an atomic number of 12. So that tells us there are 12 protons, and it has an atomic mass of 24. So we know the number of protons plus the number of neutrons is 24. So we can figure out that the number of neutrons is 12. But what about the electrons? So we know that if it's neutral, there's no charge, then the number of electrons equals number of electrons equals the number of protons. So they would both be 12. But what about when the charge is +2? So do you think if the charge is +2, will there be more protons or more electrons? So I'm hoping that you would say there would be more protons. So in order to have more positive charges than negative charges. So if this is the case, there still has to be 12 protons, because if that changes, we no longer have magnesium. So if there are 2 more protons than electrons, and we know we have 12 protons, then there must be 10 electrons. So our final answer is there's 12 protons, 12 neutrons, and 10 electrons. So next class, we're going to work on more of these, quite a few more of these on pages 27, 28, and 29. So don't worry if you're not comfortable with these yet, you'll get there. It'll just take some practice. But I wanted to do this one today just so we could do one. So in addition, the last thing for today is to just look at these and determine if we can tell the difference between an ion, an isotope, or neutral atom. So this is a page that was not in your green packet, but I added as an additional page over spring break. So if I mailed a packet to you, you should have this already printed out. If I didn't mail a packet to you, it's on P-Learning as an additional page for Chapter 4 green packet. And this is the last page in there. I think there were 3 pages in there. So we're going to do the first part together, and I'm going to do a couple of these in the table, and then I'll have you fill in the rest on your own. So we're going to use the words below to fill in the correct answers to questions 1 through 3. So number 1 is an atom with the expected number of electrons, protons, and neutrons, and it's called neutral. Number 2, an atom with a different number of electrons than protons is an ion. And number 3, an atom with more or less neutrons than expected is an isotope. So neutral, ion, and isotope. So looking at the box below, you're supposed to determine if the charge state of each atom would be neutral, an ion, or an isotope by comparing numbers of electrons, protons, neutrons, and atomic mass to what is expected in a neutral atom. So what this means is we're going to look at 2 things. Are your electrons equal to your protons? If they're not, then we have an ion. If they are, then we're going to look at the next thing. Does the atomic mass minus the number of protons equal the number of neutrons? If they do, then it's neutral, and if they don't, then it's an isotope. So let's do a few. The number 1, is the electrons equal to the protons? Yes, they're both 1. So then we look at the next thing. Is the atomic mass minus the protons, so 1 minus 1, equal to the number of neutrons? 1 minus 1 is 0. That's the same as what's here, so we know that this is a neutral atom. Number 2, the electrons equal the protons? No, they don't, so it's an ion. Number 3, electrons equal protons? Yes. So then we look at the mass, which is 7, minus the protons, which is 3, which is equal to 4. 7 minus 3 equals 4. Is that the same as the number of neutrons? No. So that's an isotope. Row 4, electrons equals protons. Yes. So then 9 minus 4 equals 5. That's the same as this number here, so it's a neutral atom. Number 5, do the electrons equal the protons? Yes. 11 minus 5 equals 6. That's the same as this, so it is a neutral atom. So now I'm going to have you finish the rest of the page. Feel free to pause it or play it the rest of the video and then come back. So polyatomic ions, if you're keeping up with these after today, there's only going to be 2 left. So sulfate, phosphate, and acetate. So memorizing them just a couple at a time makes it a lot easier. Chapter 4 test. It's going to be very, very similar to the last one. You're going to have a 1-pager, 2 of them. How to determine protons, electrons, and neutrons with examples. And you're going to have a second one where you're going to be summarizing other topics in the chapter. And you're going to be free to use whatever template you want. There's also going to be a photo project. So there will be a set of models to do, isotopes like last homework, and ions, which you will end up doing over this coming weekend. So then you're going to practice them over this weekend. After we have a chance to look at them and go over them, then you will be having that as part of your test. Your online portion is going to be very similar to last time, same site, multiple choice questions, as well as short answers. I will end up providing a rubric for your 1-pager and photo project. I'll get to them as soon as I'm feeling up to it. The timing for all of this will be next weekend, not this coming weekend, the following weekend. And I'll announce the date of the online portion around the same time. So towards the beginning of next week, I'll be able to give you a day that we'll be able to do this. But I want to be sure that we have enough time to finish this homework, kind of get caught up, get a chance for me to go over the homework next Tuesday, so that we've gone through everything. We've practiced ions and charges and electrons a little bit more before you have to deal with this test. So next week, until the end of the term, we're going to be going on Chapter 5 and Chapter 6. Chapter 5 is just about naming compounds, and it's going to depend on the type of compound. So we're going to go over rules of doing that, practicing some of them. We may not get through all of them to the point where you really know how to name them all and can do them all very, very well. But hopefully I should have a chance to introduce all of them to you. Chapter 6, we've actually done everything except for balancing equations. So I am planning on spending a little bit of time doing balancing equations. We'll kind of pause in naming compounds and we'll do a little bit of balancing, and then we'll wrap up with some more naming, because I find if we name every day and we're naming different things every day, it just gets overwhelming for everybody. So that's kind of where we're at. And turn in work due on Thursday. We kind of jumped around in the green packet. Sorry, it's a little bit, they're not in order this time. So green packet pages 8, 17, 23, and 26. And then there's an additional page from the extra part for the green packet, which was ion, isotope, or neutral. Survey forms, again, really helpful to me. Thank you so much for all of you who have been filling these out. I really appreciate it. And I do have some of the questions that you've been asking me personally. I will be going over those in another video soon. Chapter 4 bookwork, there's nothing new this time, but Chapter 6, there are 2 sections. The first section is evidence for a chemical reaction, which we've already covered because you guys already did that back in Chapter 3. And Section 6.2, chemical equations, which was about reactants and products and what coefficients are and subscripts are. So that's why I covered some of that today. So that's kind of where we are for Chapter 6. And I was asked by somebody if you could get extra credit if you were doing some of this bookwork, and the answer is yes, definitely. I am happy to do that. So looking ahead, almost done with Chapter 4. Test will be next weekend, not this coming weekend. I already talked about curation project. I'm going to post a separate video going over the Chapter 2 Part 2 test as soon as I'm feeling a little bit better and get a little bit more caught up. So I think, yep, that was it. So ladies, I hope this was okay. I know it's a little disjointed because not everything is all together for this particular class period. but I don't believe too much of what we did today is you're going to find hard or really challenging. But be sure to go ahead and fill out the survey, because I had a question on there about what do you still need practice with? What do you still need some help with? Because I need to kind of gauge that as to what else should I be posting on P-Learning? What else do you need some help with? What else do you need some more practice with? I know a few people had already contacted me with the last survey saying that they wanted some more practice with some weighted mass averages with some more of those atomic masses that we did last class and went over the rest today. So, all right, ladies. So you guys take care. I hope you guys are all doing well, and I will be in touch and talk to you next class.